Welcome TikTok, aspiring electricians and contractor schoolers. So today we're talking about, we're going to talk about cable, armored cable, right? So electricians get familiar with the definition of where a cable is concerned. It is in the National Electrical Code and also the JS316 and the IEEE regulation. So this is a cable, armored cable, and this is XLPE, and the XLPE means cross-link polyethylene cable. We also have the SWA cable, right, and SWA cable that would be steel wired armored. So again, remember now a cable now is a composite material with with about two or more conductors, right, put together with a sheet, a covering. And in this case, this is an armored cable, and here we have the armored here, the wire, the steel wire, the armored, the steel wire, which armor the cable, protect the cable. And you have the sheet, you have just taken out the sheet of it, right? And of course, the conductors inside of it, right? So sometimes a cable can have, I would say, can be 2 core, can be 3 core, can be 4 core. In this situation, this is a small, it's a 6 millimeter 4 core conductor cable, and with the color code, we are going to use this cable for a single phase, a 220 volt single phase supply. It's going to be a sub beam. So in that case, what I'm going to do, I'm going to use now, I am going to have to do some color coding too. Well, we are going to use the brown and the blue as phase, and I'm going to color code the blue, right, the red tape, and of course the black would be my neutral, right, my grounded conductor, and then I'm going to use green tape and color code this for the earth. So this is a 4 core. However, if this was a 3-phase supply series circuit, and so I was going to run this for a 3-phase motor, I would use the red, the brown, the blue, and the gray, and I would have the black, color code the black with green, have it for the earth. Electrician going forward, one thing I wanted to note, this should never be used as an earth conductor, equipment grounding conductor, right? They should never be used, right? It must only be bonded, right? So when we use our glands here, we have our glands, right? And the glands normally come with the earth pin here. And this earth pin now, you tighten this to the metal, and you use nut and bolt, right, and tighten it properly, clean the air, whatever pin on it, and tighten it properly and use it, and to bond. So we bond the metal, we bond the armor of the cable. However, as I said, now if you use for a 3-phase supply, you use the neutral, the three live leg, and use the neutral, and then you run a separate earth continuity conductor according to the same size as the phase conductor, and use that as a ground, a green insulated conductor, right? So going forward, our youngster now, we're not familiar with cable, with terminating a cable, right? It can be a little tedious, with practice you can become good at it, right? So what you normally do, you make sure you have at minimum, you want a knife, right? And this is a small cable. So in this case, I just have adjustable wrench and adjustable pliers here, and pliers and a knife to do the necessary termination, right? And if it was those big cables now going up from say like 25 millimeter, right? 25 millimeter going up, you'd need wrenches, right? Monkey wrenches to do the termination. So those big cables like those 150, 185, 240, 300, you don't have to use have some very big wrenches, 2 wrenches to do that termination. And remember now, normally now you consult your cable chart to know the appropriate, after you do your necessary load calculation according to the length, the mean, the design current, right? You do your calculation, you calculate your maximum permissible voltage up to get the rating, the cable size that you're going to use. You consult the code, there's some table in the code with the rating of the cable, right, according to the amount of current, and after you apply your necessary derating factor and so forth, then you decide that the cable that you're going to use, right, in order for your load. And remember, the cable, the breaker always protect the cable. So the breaker must not be bigger than the cable. So remember now, this is an armored cable. You also have the non-armored cable where they just have the covering. If it's a non-armored, it will have a wire inside, the steel wire inside of it, right? And remember now, I'm going to now use my straps here, right? I'm going to use a strap, and this is going to strap surface on the wall. And in that case, now I put a strap about 10-12 inches apart. Right, and ensure that my cable is strapped properly with screws and the appropriate wall plugs or blue screw. So that's it for today. Where cables are concerned, armored cable and non-armored cable for commercial and industrial application. And remember, anything you're going to do, you consult the code, right, and see where the rating of the cable, the condition of the cable is going to be operating under. And remember, you have to take in consideration now the length of the cable. The longer the cable is, right, the more voltage drop you're going to have. So you have to do a necessary calculation where that maximum permissible voltage drop, and you apply your derating factors and try not to run the cable in hostile environment, right? You want the cable to run a cool area, so you don't want to run it. So if you run it in a hostile environment, you'll be exposed to the sun, another ambient factor that affect the ambient temperature. You will do the necessary derating for it. So until next time, youngsters out there, aspiring electricians, young engineers, continue to watch, follow, subscribe, and be a part of the thing, and turn good engineers and electricians. Thank you.